Thank you for joining this lesson. We're going to do a physics lesson, paper 1, number 11 of this paper, where we're being told that a metal ball suspended vertically with a wire is displaced through an angle theta as shown in the figure below. The body is released from A and swings back to B. So the body is being released from A, then it swings until B through an angle theta. You can see it has been risen through a vertical height h. You can see the rope is 4 meters. And we can also see that the body is 2 kg. Then we are told, given that the maximum velocity at the lowest point B is 2.5 meters per second, find the height h from which the ball is released. So we're going to solve the question now. It should be understood that when the ball is held at point A, because it has some height above the ground at where it is, that body possesses what we call gravitational potential energy. Gravitational potential energy, and this one is usually calculated by the mass of the body times the gravitational acceleration of the earth times the height to which a body has been risen. Otherwise, mass and gravity are giving us force of the body, then height is the distance where it is. So the energy the body has is the work done to raise the ball to that position. But now, when the body is released through point B, the body loses what we call gravitational potential energy because the height will be reduced. But at the same time, as it reduces the height, it is going to increase its velocity until a maximum velocity. And in the given question, the maximum velocity is 2.5 meters per second. Therefore, by the time it will be reaching point B, the lowest point, it will have lost all the gravitational potential energy, but this energy will have been gained by the same body as what we call kinetic energy, because the body will be gaining a lot of speed, and the kinetic energy is usually given by half mass of the body times the velocity of the body squared. Therefore, now we can say the gravitational potential energy, which will be lost by this body, will be equal to the kinetic energy that will be gained by the same body. This is according to the law of energy conservation. Energy can only be converted from one form to another. Therefore, now we have gravitational potential energy given by mgh equals to half mv squared. For the same body, the mass is appearing twice. So instead of substituting at an early stage, we can do away with the mass. Then we substitute gravitational potential energy, no, gravitational pull, that is, then times the height, which is unknown in this case, multiplied by a half, and the velocity of the body. And the velocity has to be squared. Therefore, now we're going to have h remaining here, and we take 2.5 squared, we divide by 2. Then now we divide by 10 to remain with h alone, and this is going to give us 0.3125 height in meters.